Okay, so today we're going to talk about section 4, which is determinants. We might even do a few examples already kind of reaching into section 5 today so that you can see the use of a determinant. But tomorrow we'll do our last section for the chapter, section 5, which is mainly about how you can use the determinants to, again, solve systems of equations. So when you think about it, you have all the methods from chapter 7, algebraic, substitution, elimination, to solve a system of equations. You have from chapter 8, augmented matrices, writing them in row echelon form. You have inverse matrices, writing the matrix equation, multiplying both sides by the inverse. And then you also will have what is called Cramer's rule. So that'll be 3 ways to solve a system. Remember that after chapter 8, you'll be able to kind of really think about how do you like to solve a system? Which way works best for you? Which way could you know going forward? Always lean on if you were ever asked to solve a system or you ran across a system that you needed to solve. You'll have that option. However, on the test on Friday, I will ask the question like solve by this method, so you need to know how to kind of move through all the different methods and matrices. Okay, so make sure that you're putting that as a focus as part of chapter 8. Okay, so today we're going to talk about determinants. A determinant is a real number associated with a square matrix. So notice that a lot of the stuff that we have done with matrices, including inverses, identity matrix, has to do with the square matrix. And so determinants, we'll only do determinants for square matrices. We will work on 2 by 2 and 3 by 3, and we'll be able to calculate the 3 by 3 matrix without a calculator. Okay, unlike the inverse, we did not do a 3 by 3 without a calculator. Okay, so key piece here is it is just a number. Okay, it is not another matrix. The determinant is just a number. There are many uses for the determinant. We'll get more tomorrow. One of those tomorrow will be how to solve the system. So that's been a huge goal for us in Chapter 8 is solving systems. And we'll do more of that tomorrow. We might get to some of the uses today. Okay, we'll kind of see how it goes. So first thing we want to talk about is the notation and the calculating of the determinant. And we'll use, for the 2 by 2 matrix, we'll use that same matrix we used for inverses, A, B, C. Now, there are 2 methods of notation. You remember you have a notation for inverses, which is just the matrix name, A, and then you use that -1 exponent to say A inverse. Okay. If you want to talk about a determinant of a matrix A, then you have 2 notations. Okay, so one of them is just DETA, so kind of like an abbreviation. And the other one looks very much like absolute value. Okay, so we're not actually finding the absolute value of the matrix. Okay, we are calling that the determinant. So we're using that same notation to mean something else in the matrix unit. Okay, to calculate the determinant of A here, I will take the difference of the products of the diagonals, AB minus BC. Does that seem familiar to you? Yes. So we have already kind of seen that little piece right there when we did inverses. Note that your inverse formula from last Thursday was 1 over AD minus BC times that matrix, GA negative B negative C. We could now say, we could write a new formula where we don't have the AD minus BC. We could just say 1 over the determinant of A. The determinant of A is that difference of the diagonals. Okay? So determinant is just going to be whatever that number is. That goes back to that piece right there, that the determinant is just a number, not a matrix. Let's look at an example then. Find the determinant of the matrix. Can be hard. Jesus, what'd you get for the determinant of A? -1 minus 6. Notice that I switched my notation from the previous slide. Now I'm using that thing that looks like the absolute value, but I would read that as the determinant of A is -7. Please calculate the determinant of B. Share with your shoulder buddy, the person next to you, make a group of 3, make a group of 3 for today. Share with the person next to you, what did you get for the determinant of B? Did you get 10? Okay. Notice again, I can switch back to that other notation. I can use DETB. So be comfortable reading it either way. Okay. And the last one, please calculate the determinant. Grace, what did you get for the determinant here? What's that? 0. Very good. So this could, we can take this discussion back to that inverse section that we talked about, section 8.3, and I could then ask, which of those matrices, A, B, or C, does not have an inverse? Matrix, oh sorry, thank you. Matrix C, right? Because we had the discussion in our small groups that day when we talked about inverses, that there would be no inverses if AD minus BC was equal to 0, because then you'd be doing 1 divided by 0, which would be undefined. So we can also look at the determinant to determine whether or not something has an inverse matrix. Okay? Pretty easy stuff, right? Okay. Now, 3 by 3 is going to be a little bit different. It'd be nice if it was just the same, and if I could just make 1x. But the issue with that is then you wouldn't use up all your entries in your matrix. Like if you could think about one diagonal going down left to right, one diagonal going up left to right, we would never cross like the D and the F. So those entries wouldn't play a role in the determinant. They really should play a role in our determinant. So here's how we calculate a 3 by 3 determinant. Okay. Essentially what we want to do is do all the diagonals. So we want the diagonal going down, AEI. And then we want the next diagonal, BF, but it would really like wrap around and hit G. Okay. And then we would want this diagonal C, which would wrap around and get DH. To make that happen very easily, copy the first 2 columns. A, D, G, B, E, H. So if you're calculating the determinant of a 3 by 3 matrix, copy the first 2 columns. So that when you're calculating the determinant, you want all the diagonals going down from left to right. Okay. So one of those diagonals is AEI. Right, I would multiply them just like I did A times D. And then I'm going to add to that the next diagonal going down, BFG. And add to that the third diagonal, CDH. I'm starting from the top of every entry in that first row, getting that diagonal going down. Okay. And then I have to subtract from that, because we're doing the difference of the products of the diagonals. Okay, so there's going to be a minus sign right here. I've got to do all the diagonals going up. So then I would have GEC, add to that HFA, add to that IDB. So you're going to multiply the three numbers in the diagonal. You'll have three diagonals to add together, those products. And then you subtract. Always make sure you subtract. You put in front the ones going down. That should be your leading number. And then the diagonals going up should be what you subtract. Okay? So here on these, think about Friday tests. It's going to be no calculator. You're going to have to be very careful with your multiplication. When I do determinants for 3 by 3s, I always draw those lines. And as I draw the lines, I do my multiplication. Okay? So let's look at an example of a 3 by 3 matrix. Matrix A is, I'll read the rows here if you want to copy it into your first row, 1, -2, -1. Second row, 0, -1, 2. And third row, 1, -2, 0. So first thing I would do is copy my first two columns, rows, columns, 1, 0, 1, -2, -1, -2. You don't need to copy the third column because you'll get your full diagonal with just the first two. And then do your first three diagonals going down. So I would start with 1 times -1 times 0 is 0. -2 times 2 times 1 is -4. And -1 times 0 times -2 is 0. Another thing that some people will do to be helpful in terms of keeping track of their diagonals, so they can go back and check their work, is you might write your product right at the end of your diagonal. So 1 times -1 times 0 is 0. -2 times 2 times 1 is -4. And -1 times 0 times -2 is 0. And then you're adding those up. Okay, so you might also show that. Subtract from that my diagonals going up. 1 times -1 times -1. It's now a positive 1. -2 times 2 times 1 is a -4. And 0 times 0 times -2. 0. Get your sums. -4 minus -3. So the determinant of this matrix is -1. It is a single real number. Okay, not a matrix. And just a real number. Thoughts about the 3 by 3? Any questions? Again, I would say here it's just a matter of being organized and taking it slow. Okay. Lots of those things that I warned you about way back when we first started matrix operations, like 2 times 3 is 6, not 5. Okay. When you do 1 times 1, you get 1, not 2. Okay. Those things seem pretty obvious, but we make a lot of those like small mental math mistakes, so you have to be really careful. I would suggest this, like, going forward. I mean, I'm not going to give you these types of determinants on the test because you're not allowed to use a calculator, but I would certainly choose a calculator if my square matrices were larger than 3 by 3, or if I had really big numbers in a 3 by 3, or perhaps lots of decimals. Then I would probably work smarter, not harder, and use a piece of technology. If you want to practice with your graphing calculators later, you can certainly go in, you would enter in your matrix, and then when you go to your matrix, what is that menu called? The math menu?
Yep.
Or calculate? Math. When you go into the matrix and you click math, one of the options is DET. So that would be your determinant. And then you would call on your named matrix that you want to do the determinant of. Okay, so you can use your calculator. We won't need to on the homework. Okay, here's one of the uses of the determinant. Finding the area of a triangle with vertices on the coordinate plane. This won't be on your homework tonight, this will be on your homework tomorrow, but by doing a couple of the uses of a determinant today, we have more time each day to do a little bit of work, especially since tomorrow is Wednesday. If you want to calculate the area of a triangle using a determinant, you're going to say that the area, so A means area here, instead of matrix A, okay, the area is equal to, and I'm going to use that, like what looks like an absolute value bar instead of the matrix bracket. Okay, so I'm talking about a determinant. And you create rows. X sub 1, Y sub 1. The third column is just going to be 1. The next row will be X sub 2, Y sub 2. The third column will be 1. And X sub 3, Y sub 3. That last column is just 1. I forgot one little piece, of course. And then think about the normal area for a triangle that you know probably from geometry and middle school math, something like 1/2 times base times height. The area of a triangle is always half the area of a rectangle here. So we would do plus or minus 1/2 times that determinant, where we put in the ordered pairs, the third column will be a 1 there. Now, it says plus or minus, but of course, you're not going to have what type of area? Negative area. So when it says plus or minus, you might make a note here, choose appropriate value. So area is positive. Choose the appropriate value so the area is positive. So if your determinant comes out to be a positive number, then you would multiply it by a positive 1/2. If your determinant happens to be a negative number, then you would multiply it by negative 1/2, so your area is still positive. Let's look at an example. So let's put that to use. Okay, let's calculate the area of a triangle with vertices at 0, 0, 4, 1, and 2, 5. So certainly you might have some methods that we could try to employ from geometry, where we graph the triangle and look for base and height or calculate altitudes. But we can also use the matrix determinant to help us. So I'm just going to plug those into that formula that I gave you. So area equals, and then I usually just write plus or minus 1/2. I'll decide later. And then I drop in my coordinates. First coordinate 0, 0, followed by a 1. 4, 1, followed by a 1. And 2, 5, followed by a 1. So the third column is always 1. I'm using not matrix brackets, but the symbol for determinants with a matrix. Could you guys work on finding that 3x3 matrix for me? So here's some practice with that 3x3. Copy the first 2 columns. I got the determinant of the 3 by 3 to be 18. As I walk around, I see most people getting there. And remember, any diagonal that has a 0 in it, it's going to be 0 when you multiply it out. So that works out really nicely. Don't forget that when calculating the determinant, you add up all the diagonals, but then you subtract. Okay, so if you had 22, you have that wrong sign in between the sum of the products. Okay, and then because it's a positive 18, I would choose to multiply by positive 1/2, so the area of my triangle is 9 square units. And I just have calculated the area of the triangle.
Okay, so why didn't you select positive?
Because if I took 18 times the negative 1/2, then my area would have come out to be negative 9. And in geometry, remember, always your answers were positives. Positive length, positive area, doesn't make sense to say negative. Until, of course, maybe you get to calculus and you start calling things negatives. Okay, and one final thing that we'll talk about today, another use of a determinant, but you're not going to see this on your homework until tomorrow, is how to determine if points are collinear. Okay. So looks very similar to the setup or the start of finding area of a triangle, because you get 3 points. Right? Any 2 points can always be collinear, because you could draw a line through any 2 points. Okay, so if you have 2 points, are they collinear? Yes, on some line. Okay, so you'd really start testing for collinear at 3 points, which is why you're getting 3 ordered pairs. These points are collinear, and I know we've seen this before, if and only if this is true. So the 3 points will be collinear if and only if the determinant is equal to 0. Can anybody make a connection to our area of a triangle? Why would that be true that these points be collinear if the determinant is 0, based on what we just talked about to the area of a triangle? Steve, your thoughts?
Because if you have 3 points, typically they would make up a triangle. And a triangle can only have you're solving for the area of a triangle. And a triangle can only have 0 triangle. A triangle can only have 0 area if it doesn't exist.
Yeah, like the space inside the triangle would be 0 if the 3 points were really on the same line, right? Because if I have 3 points that are non-collinear, about 3 non-collinear points, when I connect those 3 points, I get space. And even if they're almost collinear, I still have space, right, in the triangle that I can solve for the area. Okay. As soon as I put 3 points on the same line, do you have any space inside the triangle? No, you don't have a triangle at all, right? You really just have a line. So if you make the connection back to that other formula with the plus or minus 1/2, I mean, I took away plus or minus 1/2, okay, because anything times 0 would just be 0. So if the determinant is 0, then the area would be 0, and the points would really be on the same line. There would be no space inside the triangle. Okay, so you can kind of make a connection. They're really the same setup. Okay, so are these points collinear? Find the determinant with a 3 by 3 matrix. If the determinant equals 0, that would mean the area of the triangle for the 3 points would be 0, which means it wasn't a triangle at all. The 3 points were on the same line. So you have the points -2, 4, 3, 1, and 6, -4. And again, for some practice for your homework tonight, go ahead and calculate that 3 by 3 determinant. Are you getting the same sum of products as I am? Have I made any mathematical mistakes? At this point, we could say, what about those 3 points? Not collinear, right? There's some space there. It would be 10 minus 26, so negative 16. That means they must be forming some kind of triangle. What would the area of that triangle be?
12 square units.
8 square units. Do you have 10 and 26?
Nope, I had 34 and 10.
I'm guessing you didn't get a negative 12. Check to see if you missed a sign. Oh, negative 34?
No, I got 34 minus 10.
Yeah, oh, okay. I would check, well, I'd check both of them then. If you have written out like your numbers, check to see if you have the same signs. It seems like most of us would agree with a negative 16 determinant, okay? Which would mean if we calculate the area of the triangle, we would multiply by a negative 1/2, so that the positive area would be 8 square units. Okay, found it? Good.
Yeah, I must have made them.
Okay, so those are just 2 uses of determinants, but you won't practice those until your homework assignment for tomorrow. So if you want to look ahead on the gold sheet, you could find those problems that are area of a triangle or collinear in section 8.5, and you could do some of them tonight if you wanted to. But we'll talk about more of the uses, especially solving systems, and then we have one other one, writing an equation of a line from a determinant. We'll talk about those tomorrow. So we have about 15 minutes. I'd like for you to get out your books, share with people if you didn't bring a book, or take a quick picture on your phone, and get started on page 579 so that you can ask questions. Remember, we're preparing for our test on Friday. We all want to be prepared for Friday. And the retake deadline for Chapter 7 is next Tuesday, November 15th. You do not have to wait until the last minute.